Hey Gomez gang, we are on Unit 5, Lesson 10. We are knocking these videos out one by one, day before the quiz so that you guys are best prepared. So let's make sure that we get through this as quickly and as efficiently as possible. Question 1. Ashley surveys a random sample of 25 students in her school and asks them how many hours of sleep they got the night before. The dot plot below shows that data. So as you can see, most of those 25 kids get between 7 to 9 hours of sleep for the most part. But the question says there are 350 total students in the school. Based on the results, how many students do you think got at least 8 hours of sleep? When we're talking about at least 8 hours, we're talking about people who got 8, 9, 10, etc., etc. So 8 or more. So when I look at this dot plot, I see how many people got 8, and there's 4. How many people got 8.5, which is 2. How many people got 9, which was 5? 9.5, we got 1 student. 10, we have 2. And there's actually none that had more than 10 hours of sleep. Sucks for them. So 4 plus 2 is 6, plus 5 is 11, plus 1 is 12, plus 2 is 14. So there are 14 people that fit my description that I'm looking for. My favorable outcome is I'm looking for those people who had 8 or more hours of sleep. Now there are a total of 25. So 24 is the total sampled or polled, and 14 is the criteria that matches my situation. So if there are 14 out of the 25 people who matched my criteria, I want to know that if there were 350 children, which is the total amount in the school, how many of them would match my criteria? Because it's a random sample, we can assume that whatever data we get from a small group would be the same for our larger group once we scale it. So this percentage should be the same in the larger population as well. To get from 25 to 350, you need to multiply by 4 to get to 100, 12 to get to 300. That means that it's 14 to get to 350. I need to do the same to the numerator. So 14 times 14 will get me to 196. So out of my 350 scholars in the school, 196 should have gotten at least 8 hours of sleep last night based on my sampling. Again, the reason why we do sampling is because we don't have enough time or energy or resources to poll all 350 students or the entire population. So what we'll do is we'll take a smaller group, and as long as it's random, the data should look very similar to the larger population. Now, question 2 is a little bit different, all right? And I'll zoom out just a little bit. A quality control researcher at an electronics company is testing the life of company's batteries in a certain camera. The researcher selects 100 batteries at random from the batteries produced that day and finds that the life of these batteries has a mean or an average of 342 pictures with a margin of error of 18. Oh, we got some error here, right? Interesting. So the mean is 342. That is my average. However, because there's an error that can possibly exist of 18 pictures, that means that it can be 18 less or it can be 18 more. Now, 18 more would lead me to 360, and 18 less would lead me to 324. So that means that the average can be 324 or the average can be 360. Again, we're talking about average. This does not mean that every single battery will have 324 pictures of battery life or 360 pictures of battery life. All we know is that this is an average. So the question is asking you which of the following is the most appropriate, right? Most appropriate based on this data. So answer choice A, all the batteries produced by the company that day have a life between 324 and 360. Now that would be incorrect because it says all of the batteries. I didn't say all of the batteries were between 324 and 360. I said that the average could be between 324. And as you know, the average is a compilation of numbers that are above the mean and below the mean. So it can definitely be below 324 and it could definitely be higher than 360. Secondly, it still says that all the batteries produced by the company ever have between 324 and 360. That's even more extreme because all we did was get it from one day. It's kind of hard to get that piece of information for the entire company forever. So I'm definitely going to eliminate both of those two. Now I'm looking at C. It is plausible, which means that it's possible that the mean life of batteries, so the average life of these batteries, that day that the company produced, so that day, is between 324 and 360. Now that's what we talked about. The average is between 324 and 360, the average. Not every single battery, but just the average. So that sounds like it's about right. But let's double check with D. It is plausible that the mean life of the batteries ever produced by the company is between 324 and 360. So the only difference between C and D is that C represents the data from that day or is making a conclusion just based off of that day, and D is ever produced. Now, again, all we did was get information from one day. That one day is only going to tell us about that day's productions. It's going to be very difficult for me to, hypothetically speaking, compare that to 6 months ago, the batteries that I produced on that day, or 2 months from now into the future. So I can't really base that information of ever produced at the moment because all I've done is for that day. And I would probably assume that most batteries have an average life of 324 to 360 pictures, with again, some being over 360, some being under 324, but most of them landing in that area. I hope that helps.